Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next video, next module, next problem. Problem number 4, fluid mechanics. Okay. Fourth problem of fluid mechanics. First we come towards its statement. A fish maintains its depth in fresh water by adjusting the air content of porous bone or air sacs to make its average density the same as that of the water. Suppose that with its sacs collapsed, a fish has a density of 1.08 gram per centimeter cube. To what fraction of its expanded body volume must the fish inflate the air sacs to reduce its density to that of water? Okay, we have to find out fraction of its expanded body volume must the fish inflate the air sacs to reduce its density to that of water. Dear students, here main consideration is about density. Density of fish is given, which is 1.08 gram per centimeter cube, and on the other hand density of water is also a constant and can be found from table of densities. Okay, first we go towards the table of densities. Okay, this is the table of densities. Okay, densities of some common substances. Here on left column, this table has two columns. Okay, on left column at serial number 5, density of water is given as 1.00 into 10 raised to the power 3, that is to say 1000 kilogram per meter cube. Okay, density of water is 1.00 into 10 raised to the power 3 kilogram per meter cube. Okay, now we come towards its solution. Dear students, while solving this problem, we first make several denotions. Okay, we fix several quantities by some alphabetical arrangement. Okay, let VF, where F is written as a subscript of V stands for volume. Okay, let VF be the volume of the fish with its air sacs collapsed. Collapsed means not inflated, gathered in a short form. Okay, here dear students, V stands for volume, while rho, this P type symbol rho or HO rho, this stands for density. Okay, M stands for mass. So first we denote these symbols. Okay, let Vf be the volume of the fish with its air sacs collapsed. Similarly, in comparison to this, let Va be the volume of the expanded air sacs, that is inflated fish. Okay, expanded is taken in the sense of inflated fish. Okay, so we have two volumes. Vf, volume of fish with its air sacs collapsed, while Va, volume of the expanded air sacs, that is inflated fish. Okay, similarly, now we come towards rho. We will categorize rho into three categories. Okay, let rho f, here again f is written as a subscript of rho. Let rho f be the density of the fish with its air sacs collapsed. Okay, in the same way as Vf was for air sacs collapsed, here f is rho f. Let rho f be the density of the fish with its air sacs collapsed. Similarly, let rho a, here again a is written as a subscript of rho. Let rho a be the density of the expanded air sacs, that is inflated fish. Okay, in the same way as Va was volume of expanded air sacs. Okay, rho a be the density of expanded air sacs, that is inflated fish. Similarly, let rho w be the density of water. Now we come towards the mass, which is constant. Okay, let mf, here f is written as a subscript of m. Let mf be the mass of the fish. Now, volume of water equal to Vw. Here W is written as a subscript of V. Okay, becomes equal to Vf plus Va. What is Vf and Va? We have already explained in the first two lines of our solution. Okay, now volume of water equal to Vw is equal to Vf plus Va, where Vf is the volume of the fish with its air sacs collapsed, while Va is the volume of inflated fish. Okay, dear students, here we come towards the definition of density. Okay, as in our previous three modules we have defined this term. Density is mass per unit volume. If a mass m of homogeneous material has volume V, then its density rho is given by rho equal to m over V. We have given equation number 1 to this expression name. Okay, we have given name equation number 1 to this expression. Now, we know from table of densities that density of water, that is rho W, is 1.00 into 10 raised to the power 3 kilogram per meter cube, which alternatively becomes equal to 1000 kilogram per meter cube. Okay, if we omit 10 raised to the power 3, then we will have to convert 1 into 1000. Okay, 1000 kilogram per meter cube. It is given that density of fish, that is rho f, is equal to 1.08 gram per centimeter cube. Okay, dear students, here we can see that density of water is in kilogram per meter cube, while density of fish is in gram per centimeter cube. It does not make very much difference. However, we convert either gram per centimeter cube into kilogram per meter cube, or we convert kilogram per meter cube into gram per centimeter cube. Okay. In this way, density of fish becomes alternatively equal to 1.08 into 10 raised to the power minus 3. Okay, because 1 gram is equal to 10 raised to the power minus 3 kilogram over 0.01 meter cube, because 1 centimeter is equal to 0.01 meter cube. This alternatively becomes equal to 1080 kilogram per meter cube. Okay. Now both densities have taken the similar form. Okay. Because dear students, here when meter will become cube, 0.01 will also be multiplied 3 times. So it will take the form as 1080. Okay. One density is 1000 and the other density is 1080. Okay. So both densities are nearly equal. Now equation number 1. In accordance with equation number 1, we have developed equation number 2 and equation number 3. Sorry. Yes, there is a mistake. This is equation number 2. Okay, dear students. This is equation number 2 and this is equation number 3. It will, for the time being, we ignore, while dear students, here I tell this is math type. Okay. Actually, I can ignore this mistake, but it is better if I clear everything in front of screen. Okay. This is math type. This is okay. Here this is equation number 2 and this is equation number 3. Okay. And now again dear students, instead of ignoring this mistake, okay, this is okay, this is now this is enlarging this. Okay. Yes, I think it is. I have removed that mistake. In accordance with equation number 1, we have developed equation number 2 and equation number 3. That is, density of fish is equal to mass of fish over volume of fish VF. That is volume of the fish with its sacs collapsed. Okay. This is equation number 2. This implies that from here MF will become equal to rho F into VF. And equation number 3, density of water is equal to mass of fish over volume of water. We know that volume of water is equal to volume of fish with its air sacs collapsed plus volume of inflated fish. Okay. So in accordance with equation number 1, we have developed equation number 2 and 3. Okay, this implies that mass of fish will become equal to density of water into volume of water from conservation of mass of fish. Okay, because mass of fish is constant and does not change. So we can say that from conservation of mass of fish, or we can say that equating equation number 2 and 3. Okay, because equation number 2 is also equal to mass of the fish and equation number 3 is also equal to mass of fish. So when left hand sides of equation number 2 and 3 are same, then right hand side will also be equal. So density of F into volume F is equal to density of water into volume of water. This implies that density of fish over density of water becomes equal to volume of water over volume of fish with air sacs collapsed. Okay, this is air sacs collapsed. In the next step, this implies that, dear students, here 1000 is the density of water while 1080 is the density of fish. So it means in the next step we have taken reciprocal of this expression. Okay, here we have this is density of water over density of fish equal to Vf over Vw. Okay, here then in the next step we have used value of density of fish and density of water. From here the fraction as in the statement given, fraction to what fraction? Okay, so here fraction Vf over Vw becomes equal to 0.074, and if we multiply this fraction by 100 then we will get a percentage. Okay, to this extent our answer is almost complete, 0.074. But in the next step we have multiplied it with 100 and converted it in percentage. So our solution has become 7.4%. Now we come towards, we have discussed this table in our previous step. Now we come towards reference book from where this problem has been chosen. Reference: Fundamentals of Physics Extended, Holiday and Resnick, Journal Walker. Its publisher is Wiley. Its 10th edition 2014 or 11th edition 2018 is being followed. Here chapter number 14 under title Fluids is our concerned chapter, and this problem is the first exercise or first module of this chapter, that is exercise number 14.1, and this is the end of our module. Okay.